Hey everybody, this is Mr. Beckstrom, and here I just want to take a look at this is section 7.6 on polar coordinates, and I want to do a couple of examples here. So here I just kind of came up with 5 polar coordinates. I want to talk a little bit about them, and I also wanted to graph them. Here I'm only using the degrees, but we could have just as easily done a graph with radians and done these with radians as well. So if we did these with radians, we would have just had the angles in radians, and then on the right side of these points, it would have been radians with the equivalent radians instead of degrees. But in this exercise, we're just going to be using degrees, and we're going to see how we graph them. Now remember, polar coordinates are just like our rectangular coordinates. Just like, if we have a 2, 3, we can also represent that point in polar coordinates. So we're going to see how we do that. And we're going to see how we convert between our rectangular coordinates and the equivalent polar coordinate. And we can go back and forth between those. All right, so first of all, let's say this was our polar coordinate graph, and let's see where these points would go on it. So just as if we were to have like an XY graph and we were to say, okay, where does 2, 3 go on it? Well, we go to the right 2 and we go up 3. We're doing the same kind of thing with a polar coordinate graph. We're going to say, okay, where do these points here go on it? Now, with the polar coordinate graph, I like to start with the angle first, so the right side first. And then I look at the radius. So we have the angle, that's the second value, and then the radius, which is the first value. So the angle says 90 degrees, so we start at 0. So I go to 90 degrees. That means I'm pointing up. And then I look at the radius. The radius is a positive 3. That means I go in that direction 3 units. So I'm going in the up direction 1, 2, 3 units, which means that 1, 2, 3, this point right here would be my A. And that's it. That's it. The tricky part here is when we get down to this negative radius, and we're going to see how to do that when we get down there. But let's go ahead and finish these other points off. So B, I start with my angle here. So I start 0, and I go around here to 180 degrees. So the angle is pointing off to the left, but I go 0 units in that direction starting from the origin. So B is going to be right there at the origin. So I'm just going to put my B right here, and that's going to be right there at the origin. C, negative 540. I might go ahead and use my coterminal angles with my calculator to figure out what direction that's actually pointing in. So if I start with negative 540, I can add multiples of 360 until I get an angle between 0 and 360. So I can add 360 again. Just add complete circles. That's the same as 180 degrees. So once again, that's pointing straight to the left, and I'm going positive 2 units in that direction. So 1, 2. So that's going to be right there. So that is my C. Now D, once again, I start with the this angle, negative 90. If I wanted to, I could use coterminal angles to put that in standard position, which would be 270 straight down. Or if I know how angles work, I start 0 and I go negative 90. So that's going in the clockwise direction, 90 degrees. So I know that's down. So it's this angle down here. So I'm pointing straight down. And then I go to my radius. Now my radius is negative 5. So that means I'm not going in the same direction as my angle. A negative radius means that I'm going in the opposite direction of whatever direction that my angle is pointing in. So since my angle is pointing straight down and I have a negative radius, then I go in the opposite direction, 180 degrees away from whatever direction my angle is pointing in. So I'm pointing straight down. Negative 90 is straight down, but I have a negative radius. So I go up 1, 2, 3, 4, 5. And my D value, that point, oops, that point will be right here. So that is D. All right. Now the last one here, 90 degrees and 5. So I start 0. I go up to 90 degrees and I go 5. It is a positive, so I go in that direction. 1, 2, 3, 4. Oh, look, it's the same point as D. So D and E happen to be the same point, and I did that on purpose to show you that I can list the same point in two different ways here, unlike rectangular coordinates where you really can't do that. 2, 3 is kind of this unique point, whereas negative 5, negative 90, and 590 can really be written two different ways, but they represent the same value. All right, so this is all 5 of these points here. So the trickiest part is to understand how a negative radius works. First, you find the direction of your angle. So for example, if your angle was pointed in the 150 position here, if I had an angle that was 150, but I had a negative radius, I would go 150 plus 180, right? Just because I go 180 degrees away. So that means that my radius was going in the direction of 330. So I would count that many units in the 330 direction. Right, that's what a negative radius means. All right, so let's go ahead and convert a couple of these points over to rectangular points. So let's go ahead and do A here. So x is going to equal r cosine theta, r times cosine of theta, and y is going to equal r times sine of theta. These are the formulas that we're going to have. And if I look at A right here, I mean, that's, if I was going to put this on a rectangular coordinate system, isn't that just going to be 0, 3? So I should be expecting that A is going to be equal to 0, 3 in the rectangular coordinate system. So let's make sure. So I should be getting a 0 for x and a 3 for y. So let's see if that happens. So for A, let's plug the values in. X is equal to my radius for x, or for r, is 3 times the cosine of 90 degrees, and that's equal to 3 times the cosine. What's the cosine of 90 degrees? That's the x value at 90 degrees, which is 0, right? Times 0, which is just equal to 0. So sure enough, we get 0 for x, and then for y, that's equal to 3 times the sine of 90 degrees. 90 degrees, and that's just equal to 3 times the sine of 90 degrees is 1, so that's just equal to 3. So my x is 0, my y is 3. Sure enough, that's what it looked like. So it's not going to be too hard when our points lie on the axes. We can just kind of tell what they are. It's going to be much harder when they lie somewhere in the middle of these quadrants. They're non-quadrantal angles. All right, so try a couple of these. Make sure that you're getting these, and that's it. I'll try to go over a couple of more as I see questions in the forums, and I hope you all have a great week. Thanks.